Solving equations with two variables. There are two different cases in which this can be. A case like this one here, where there are two of the same variable, in this case it's both x, and this case over here, when there is one variable that is x and another that is a different variable, in this case I chose y. And we'll go over this left side first. So again, as with all systems of equations, you want to try to isolate one of the variables. And in this case, we're going to isolate this x. And to do that, we want to bring all of the x terms onto one side. So since this left side has 4x and 4 is greater than 2, I'm going to try to get x on the left side. So we'll do subtract 2x from both sides. And this is going to be 0. And this 4x minus 2x is going to be the same as if we just did 4 minus 2. Except now there's another of the same variable on both. So it's just 4x minus 2x will give us 2x. And don't get confused by subtracting things of the same variables. You can basically remove, and which later you'll learn is like factor out the x, do the problem inside, so 4 minus 2, and then add or multiply that x back on later. All right, now we just use rules for addition and subtraction and multiplication division in order to get this alone, and this is going to give us 0. This 28 minus 10 will give us 18, so we get 2x equals 18. Now we'll divide both sides by 2, and we know that this will give us a 1, which will leave x alone, and 18 divided by 2 is equal to 9, and that's our answer. So now when you're given an equation that has two different variables, you always want to set one of the equations in terms of the other. And that might sound a little confusing, but really what that means is you want to isolate one of the variables while leaving the other one and on the other side, as well as all the numbers on the other side as well. So in this case, I'm going to want to find this in terms of this y here, which means I want to do all that I can in order to get the y alone. And along the way, I'm going to simplify. And I'll show you how I'll do that as we go. So the first step I'm going to do is going to expand out all these parenthesis expressions I have. So I'm going to start by coming here and going, all right, 7 times x and 7 times negative 4. And I'm going to rewrite that as 7x minus 28. I'm going to come here and it's going to be 3 times y plus 3 times 5, which is 15. And I'm just going to rewrite this whole expression. So we get this whole we get 7x minus 28 minus 2x equals 19 plus 3y plus 15. And so now we can combine all the like terms. And so we're going to get 7x minus 2x, which is going to give us 5x, and this 28 is alone, so we just keep that there. Then on this other side, we're going to have 19 plus 15, which is going to give us 34. And this 3y is alone, so we'll leave it there. So now trying to get this 3y isolated. That is our goal right now. So we'll subtract 34 from both sides. That is going to give us 5x, and negative 28 becomes a more negative number, so we're going to get negative 62 is equal to, and we know this becomes 0, 3y. And now to get this y alone, we will divide both sides by 3. And I'm going to leave this in fraction form. This becomes 1. And so we're going to get that 5x divided by 3 minus 62 divided by 3 is equal to y. And just so it's easier to read, we can rewrite that the other way around. So 5x minus 62 divided by 3. And I write these in two different ways so that you can see that these are equivalent ways of writing the expression. And that is how you solve in terms for y. So if you wanted to get this in terms of x, then I'll just run through it quickly and you can try it on your own. But you multiply both sides by 3, and then you will add 62 to both sides. And then finally, you will come in here and divide out this 5. And in the end, you should get 3y plus 62 over 5 equals x. And I just do this to show that it doesn't matter what variable you write things in terms of, and that'll be good to know later on.